Hello viewers, in today's class we are going to solve a very important and conceptual problem in three-dimensional geometry, right? So here we have a problem related to the intersection of two lines, right? So here we have to find the value of k if the lines x minus 1 over 2 is equal to y plus 1 over 3 equal to z minus 1 over 4 and x minus 3 over 1 is equal to y minus k over 2 is equal to z over 1 intersect, right? So we have to find that value of k for which these two lines intersect, right? So let us start. Now here we are given the equations of two lines, right? So let us represent the two lines by L1 and L2, right? So L1 is given by x minus 1 over 2 is equal to y plus 1 over 3 and z minus 1 over 4, right? And L2 is x minus 3 over 1 y minus k over 2 and z over 1, right? So here what we have to do, see, if we have two intersecting lines, right? Suppose this is the line L1 and this is the line L2, right? And if these two lines intersect, there is a point of intersection, right? So let us take P as the point of intersection, and here we are given that this line L1, it passes through 1 minus 1 and 1, right? So it passes through 1 minus 1 and 1, and the direction ratios of L1 are given by 2, 3 and 4, right? And similarly L2, it passes through the point say 3 k and 0, right? And the direction ratios of L2 are given by 1 to 1, right? So we have written the points through which the two lines passes and the direction ratios of the lines by comparing these two equations with the standard form, that is x minus x1 over a, y minus y1 over b and z minus z1 over c, right? Okay, so now here we have to find the value of k for which these two lines L1 and L2 intersects, right? So what we will do, we'll find the coordinates of the general point, right? The coordinates of the general point lying on the line, right? So what we will do, to find out the coordinates of the general point on line L1, we can take a scalar lambda here, and in order to find out the coordinates of the general point lying on the line L2, we can take here the scalar mu, right? So for some value of lambda and some value of mu, we can have a particular coordinate on lines L1 and L2 respectively, right? So if we take the first line, then we have x minus 1 over 2 is equal to lambda, then we have y plus 1 over 3 is equal to lambda, and z minus 1 over 4 is equal to lambda, right? So from here we have x is equal to 2 lambda plus 1. From here we have y is equal to 3 lambda minus 1, and z is equal to 4 lambda plus 1, right? So the general coordinates lying on this line L1 are given by 2 lambda plus 1, that is the x coordinate, then we have 3 lambda minus 1, then we have 4 lambda plus 1, right? And similarly we can find out the coordinates of the general point on this line L2, right? So for this, what we will do, we'll write x minus 3 over 1 is equal to mu, then y minus k over 2 is equal to mu, and z over 1 is equal to mu, right? So now we have from these three equations. We have x is equal to mu plus 3, and here we have y is equal to 2 mu plus k, and z is equal to mu, right? So now the coordinates of the general point lying on this line L2 are given by mu plus 3, then 2 mu plus k, and then mu, right? So the coordinates of the general point on line L1 are given by these coordinates, and on L2 are given by this coordinate, right? Now see, here we are given that L1 and L2 intersects, right? So it means the two lines are intersecting lines, right? So when these two lines intersect, there is a common point of intersection, right? So when we have a common point of intersection, then for some value of lambda and mu, right? So this is an important point here. For the common point of intersection, for some value of lambda and mu, these two coordinates must coincide, right? So now these two coordinates must coincide for this point of intersection, because this point lies on this line L1 and as well as on the line L2, right? So now we can write 2 lambda plus 1, 3 lambda minus 1, and 4 lambda plus 1 must be equal to this coordinate, right? That is mu plus 3, 2 mu plus k, and mu for some value of lambda, right? So now if we compare both these coordinates, we get three equations, right? So three equations in lambda and mu, right? So the first one is 2 lambda plus 1 is equal to mu plus 3. So this is the first one. And then we have 3 lambda minus 1 is equal to 2 mu plus k, and then we have 4 lambda plus 1 is equal to mu, right? So this is the third equation, right? So now what we will do, we'll take equation 1 and 3 to solve for lambda and mu, and then by finding out lambda and mu, we can calculate the value of k, right? So now if we take equation 1 and 3, then from equation 3 we can substitute the value of mu, that is 4 lambda plus 1 over here. So we have 2 lambda plus 1 is equal to 4 lambda plus 1 plus 3, right? So 1 and 1 get cancelled, so we have 2 lambda minus 4 lambda is equal to 3. So minus 2 lambda is equal to 3. So lambda is minus 3 over 2, right? So now if we substitute this value of lambda in equation 3, we can get the value of mu. So mu is 4 times minus 3 over 2 plus 1, and this is that is minus 12 over 2, that is minus 6 plus 1, so this is minus 5, right? So mu is minus 5, right? And lambda is minus 3 over 2. Now we can substitute these two values in equation number 2, right? So from equation 2, the value of k can be written as 3 lambda minus 1 and minus 2 mu, right? So k is now 3 times minus 3 over 2 minus 1 minus 2 times minus 5, and here we have minus 9 over 2 minus 1 plus 10, and this is minus 9 over 2, this is 10 minus 1 is plus 9, so this is minus 9 plus 18 over 2, that is 9 over 2, right? So viewers, the value of k for which these two lines L1 and L2 intersect is given by 9 over 2, right? And moreover, we can find out the coordinates of this point of intersection P by substituting the value of lambda here, right? That is x, y and z. We can substitute lambda is equal to minus 3 over 2 here, and we can find out the coordinates of the point of intersection, right? So we can find x is equal to 2 times minus 3 over 2 plus 1, y is 3 times minus 3 over 2 minus 1, and z is given by 4 times minus 3 over 2 plus 1, right? So now x is given by minus 3. Here 2 and 2 get cancelled, so we have minus 3 plus 1, so we have minus 2, and y is minus 9 over 2 minus 1, so we have minus 11 over 2, and z is equal to minus 6 plus 1, so we have minus 5, right? So the point of intersection is given by minus 2 comma minus 11 over 2 and minus 5, right? So this is how we solve this important and conceptual problem from three-dimensional geometry.